Okay, so now when we design a finite automata, right, what we did was language is nothing but it's a collection of strings. So while designing the finite automata, all the strings should be accepted by that particular finite automata. It's not that one string, different machine, another string, different machine like that. It's not like that, okay? For this particular given language, only one machine should be designed in such a way that all the combination of strings should be accepted by that machine. Now, in order to begin with, let me just take one simple example, and then we need to define this number of states. Yesterday, purposely, I haven't mentioned what will be the required states here. And then normally for a particular machine, what we require is a final state and an initial state. So in that way, what I did, I have inserted, I have defined an initial state and a final state. Okay. Now for a simplicity purpose, right? Let's just introduce only one state. Okay. You'll know later on why I'm introducing only one state here. So totally three states I'm introducing here. Okay. So my target is initially whatever it is, it will start from here, and then in the middle, this Q1. After that, it will process everything, and then it will reach final state. This is my target. That's why only three states I have just defined. Okay. And then regarding the PDA, I have already constructed the block diagram. Now, the main backbone of this particular machine is to write the transition function, okay? So now in order to write the transition functions, right, let me consider one simple string first. Let me consider this AB, okay? I'm going to design a PDA which will accept this string AB, okay? Now, let me just draw the block diagram here. This is B, then finite control. Initially, I'm going to consider this is in Q naught, and then initially we are going to assume that the stack is empty. Hence, what we're going to do is initially we are going to push one stack symbol here. We are going to, like when we consider a stack as the memory element, then we have to use push pop term. Okay, regarding this push and pop, I need not remind you guys because you all have already studied data structure and all in your previous semester. So push means we are going to insert something inside a stack. Pop means we are going to remove one particular element from that stack. And then whenever we are going to pop some element from the stack, it's nothing but the topmost, suppose I have enter A, B, C. So when you're going to pop, right, if you want to pop B, you have to pop A first. After that, the top pointer of the stack will be pointing here so that you can remove B simultaneously. Okay. Now, I'm going to design a PDA which is going to accept AB. Now, initially, what I'm planning is, initially, I'm considering that the state is at Q naught, and then everything is empty. I'm considering nothing is there initially. I'm just considering nothing is there initially. And then I'm going to push a stack symbol jet. Got it? Initially, it's quite disturbing. Initially, I'm considering nothing is there. So initially at Q naught, and then input symbol also input. This is input symbol. Input symbol also empty, and then the symbol to be replaced. Also empty epsilon, and the state will be changed from Q naught to Q1. Then jet is the stack symbol. It is going to push inside this the stack element. Okay, so let me write this as 1. Okay, so I'll just draw the diagram also. Initially, what happened is after pushing stack element jet inside, I'm changing this state to Q1. I'm changing this state to Q1. Okay. When I say input symbol epsilon means I'm not reading anything. I'm not reading anything. I'm not modifying anything from the what to say, the input symbol. Okay. Nothing is being modified there. So initially at Q naught, input tab nothing, and then I'm not going to modify or replace anything from the stake symbol. Everything is empty. Now this epsilon from the this is stake symbol. Okay. This is stake symbol. Initially, I told stake is nothing but now this epsilon, it is nothing but this state, right? I'm going to change the state from Q0 to Q1. That's it. Okay. Now number two, right? Number two, what I'm going to do is what I'm going to do is I have already modified the state to Q1. Currently at Q1, currently at Q1, and then from the input tab, I'm going to read A. From the input tab, I'm going to read A. Now, initially at step number one, right? What happened? Step number one, what happened? I have already inserted jet inside the stack. So whenever it comes to stack, right, we have a top pointer. Okay, that top pointer will be always pointing towards the topmost element inside the stack. So currently the pointer is pointing towards the top pointer jet. Now what will happen is I'm going to push A inside it. Initially, this is now from Q0 to Q1, it has been changed, and then jet has been inserted in here. This is currently at Q1. From input tab, I'm reading A, and then from the stack, I'm reading the symbol jet. Now the state one changed, so Q1 as it is. Now A will be inserted on top of jet. So now let me modify this one. Let me modify. Oh, let me modify. I have inserted A here. Now instead of top pointer pointing on jet, it will be pointing towards A. Okay, this is it. Now I have inserted A there. Automatically this will start reading here. Okay. Now I won't mention anything like that. I'll just write like that. Try to understand what is the symbols mean by in here. Okay. So many of you used to get confused. Now after inserting A, right, what I like to do is, what was our string? AB. AB. Our string was AB. Okay. Now what I did, jet I have inserted, then A I have inserted, A I have inserted. Now what about B? Now currently at Q1, and then let me stop here. Whatever I did till now, anybody's having any doubt? Once you understand, right, it's very easy. So till this step, whoever is having any doubts, please raise your doubts. It's fine. I'm moving a little bit slowly, okay? So what I did, let me draw the diagram one by one and explain it. Initially, I'm not reading anything from the input symbol. Currently, it was at Q0. And then without reading anything from the input, the stack, I was thinking it was empty, nothing was there. So what I did was, initially this is zero position, okay? Zero, initially it was like this. So now, after using this transition, what happened? I'm not reading anything from the input symbol. What I did, I have inserted jet inside the stack. When I inserted jet inside this one, initially it was Q0. Now the finite control changed to Q1, and then the top pointer is pointing towards jet. and then it is always there like that, but we are not reading anything from here. Okay, and then this number 2, as per transition number 2, what happened was, let me just draw the diagram. Okay, that way you'll be able to understand. Now next one, what I did, I'm reading A from the input tab. I'm reading A from the input tab. The state has been already changed to Q1, so it is currently at Q1. A is being reading from the input tab, and then jet is already there. Jet, the top pointer is pointing towards the jet. Now what happened? We have inserted A from tab and inserted inside the state. It's not that we have it, it's not like that. Okay, symbol is different, input different. Now let me tell you one thing. I have defined text symbol A, comma, B, comma, jet, comma, epsilon. Sometimes the senior used to confuse that whatever is there inside this input tab, right? It's being take it out and then inserted in here. It's assumed in that way. It's not like that, okay? We are using text symbols separately, input symbols separately. Sometimes you may find the example like text symbols are different from input symbol, but in my example, what I did, I have taken text symbol similar to input symbol also, okay? If you don't want to confuse yourself, you can use capital letter A, capital letter B, like that, okay? It's up to you. There is no restriction. But as an advice, being a designer of a push-down automata, right? Please use what similar to input symbol for the beginners, and later on you just adapt to these new symbols like that. Okay, it's an advice for the beginners. Use the stake symbol similar to input symbol. That way it will be convenient for you. Okay, this is as per transaction number 2. I have inserted A here. Okay, now next one, right? Next one, what is my target? Next one, right? I'm going to read B. I'm going to read B. I'm going to read B. I'm going to read B from the input tab. I'm going to read B from the input tab. So let me just write. Oh, I'm going to read B. Okay, it's stuck sometimes. Okay, that is the main problem of this. So currently at Q1, and then I'm going to read B. I'm going to read B from the input tab, and the stack pointer was pointing where? A. Stack pointer was pointing, the top pointer is at A, so I've written like this. Now what will I supposed to do? The state one change Q1, and then it's a little bit confusing, right? Let me explain it. Now, currently at Q1, the stack pointer was pointing towards A. State 1 changed. Now what happened? This A, currently the top pointer is pointing towards A. This A will be replaced by epsilon. The A will be replaced by epsilon. It means what? You're popping A from this text symbol. You're erasing A from this text symbol. So we could not use the term erasing and all from this tag. So I'm just saying popping, pop A. Okay, I'm just popping A from the stack symbol. When you remove A from the stack, what will happen? The stack pointer will be pointing towards jet. Okay, now next one, what I'm going to do, just see it. Next one, what I'm going to do is, I'm not going to read anything from the input tab, because AB, when I was considering the string AB, right? After this, nothing is there, it's empty. So let me, I'm not going to read anything from the input tab. So when I say it's not going to read anything from the input tab, then it's supposed to be epsilon. Okay, now let me write currently at Q1, I'm not going to read anything from the input tab. And then currently this text symbol is pointing towards the jet symbol. Let me just write jet. And then I just want to change the state from Q1 to QF. So let me write QF and then epsilon. It means what? The stack pointer, right? It was previously it was pointing towards jet. Now I just want to replace that one with this epsilon. It means what? Pop jet. Okay. When I pop jet, now this one, right? What happens? This is A, B without reading anything. This will be changed to final state, and then state is also empty. Okay. Now this is a small part of the PDA which is designed. Actually, while designing the PDA, which the designer just accept this language. Okay, just tried for the string C. For AB, I have completed this one. Now let me tell you something. When I was discussing push-down automata, right, I have mentioned that there are two kinds of push-down automata. Either they are going to accept the given language by reaching the final state or by emptying the stack. Okay. So in my example, what I did, I've changed the state from one non-final state to final state, and then stack also empty. It may happen that, let me write or, okay, let me write or. In my case, I was making this particular PDA to accept A, B by both reaching final state as well as emptying the state. So let me write an alternative for this. Let me write an alternative for this. Let me write an alternative for this. Currently at Q1, without reading anything from the stack symbol, we are considering the top stack pointer pointing on jet. And then I just want to move towards the final state without doing any modification on the stack symbol like this. See here, previously when I was choosing this one, right, the stack was empty. Now see here, jet is still there, stack is not empty, but the state is QF. Hence, AB is accepted by this given push down automata by reaching the final state. Okay, and then let me write another one. Or currently at Q1, without reading anything from the stack symbol epsilon, without reading anything from the input tab, so I've written epsilon. Currently, stack symbol is this, and then I don't want to change the state to the final state. Let me just write Q1, and then I just make the jet replaced by epsilon. It means what? Stack is empty. Now with this one, right? Let me just draw the diagram. This is A, B, and then the state is still Q1, but stack is empty. Okay, so here with this one, right, AB is accepted by this machine PDA by emptying the stack. Okay, these are two kinds of PDA which I have discussed yesterday, like acceptance by what to say. Uh, Reaching final state or emptying state. It's up to you. Whenever I ask you guys to design a PDA, right, it's up to you whether you're going to design a PDA by reaching the final state or a PDA by emptying the state. But what you need to do is you have to mention priorly. Like, let's say, for example, yesterday I've written this example. Design a PDA which accepts the language this, which has equal number of A's and B's like that, right? Solution I have just initiated like this, but I didn't mention anything. So for you guys, right? So we are going to design a PDA which is going to accept by final state, by reaching the final state, or by emptying the state. You have to mention like this very clearly at the beginning. Now, AB completed. AB completed. Let me take another easier version. Okay, let me take another easier version. So for this easier version, right, let me just write another one. Let me just write another one. AABB. Okay. Now next one, right, let me add few transition function which will be accepting AABB. I've already told you need to design a PDA which has to accept all the strings present in here in this set of language. So now AB completed. Now let me design for this AABB. Okay, let me design for this AABB. Now let me tell you something. This is for your explanation purpose. Let me just remove it. Remove in the sense, will not consider this for the moment. For explanation purpose, I have just written this part. So for the time being, just imagine that this is not in here. Okay. Now, AB completed. Now let me design for this AABB. Let me design for this AABB. AABB. Now again, same thing will happen. Consider that state jet push inside it, Q1. It's been changed to Q1. Okay. So number one change. And then next, number two, what happened? Number two also one change. We are going to use two transition number two. Currently at Q1, you're reading A from the input tab, and then the stack pointer is pointing towards the stack element jet. So you are not going to change the state Q1. What I'm doing here means you are pushing A inside the stack. So let me push A inside the stack. Let me push A in here, and the pointer will be pointing towards this. Okay. Okay. Then next one. Next one. Do I need to insert any transition? Yes. Let me just insert by setting number 5 here. Number 5. Q1, currently at Q1, reading A from the input tab, reading A from the input tab, and then the stack pointer, the stack element, right? The top pointer pointing towards the stack is A. So what will happen? I'll just push A inside the stack. Okay. After reading A, what happened? I have just pushed A inside that one. After reading A, no, it is already read. Wrongly, I was writing like this. So A inserted in here. Okay, A inserted here. Okay. Now what happened next? I just want to read B. I just want to read B. Yes, this one can I use? I'll just check. I just want to read B. When I read B from the input tab, the stack element, the stack pointer is pointing towards A. Oh. The stack pointer is pointing towards the element A. So when I'm going to read, no, wait a second. Sir is in training and placement room. Okay. So when I'm reading element B, when I'm reading element with. When I'm reading B from the input symbol, input tab, by mistake I have, okay. When I'm reading B from the input tab and from the stack symbol, the stack pointer is pointing towards A. What will happen? I just want to pop A. So can I use any transition function which is already present? Yes, I can use this. Currently at Q1, reading B from the input symbol and then from the stack symbol, A element, the stack pointer, the top stack pointer is pointing towards A. Then I'm not going to change Q1, simply I'm going to pop A. So I have popped A. So now what will happen? I'll pop A. So let me just rub this. I'll pop A. And then now it will be like this. It will be like this. So do I have to, can I reuse the function, this one, yes, again. Currently at Q1, I'm reading B from the input symbol, and then from the the stack pointer is pointing towards A. If it happens, then I just want to replace this A by epsilon. Again, this is popping A. So now let me just this. After this, you can select anyone. I mean, you can select anyone. Anyone means either by reaching the final state or by both. Okay. Using 4, you can continue like that. So when I try to design a PDA which is accepting AABB, another transition function is being added, which is this one. Okay. Now, what about ABB? What about, let me take another one. Let me design for another one. It's not a separate machine, okay? What I need to do is, I need to modify the transition function. I need to So our target is to design a PDA which will be accepting this language. So in order to design a PDA for a given language, what I did, I have selected the least length string, which is AB. For AB, I have done it. And then next one, what I did, I have done for AABB. Okay. Next one, you can try for another string. Now, in order to keep on explaining for one by string again and again, what I'm going to do is, I'll just write the transition function at once, and then we'll select a string randomly and then just try to check for it. Okay. Got the point? How we need to construct a transition function, how we need to design a PDA for a given language. I have explained in a very simpler manner. So now what I'm going to do is, I'll be writing the transition function at once, and then we'll try to use those transition function by selecting another string randomly. Okay, so now let me just try the transition function. Six, let me just write one, A, B, you want if and number 7. Don't get confused, okay? It's actually, it's I just want to start the test from tomorrow onwards. That's why I don't have enough time. And I've already told your midterm will be conducted only for 10 marks. Before your midterm, I'll be conducting 2 unit tests. Its previous one was 10 marks. Second one is also going to be 10 marks. So 10 plus 10 plus what? 10 plus 10 plus 10. That's the way I'm going to count your mark. Okay. Now, next one is BB. Next one is BB. Okay. Now let's just try to select one random string. Let me select this one. Let me select this one. Okay. Let me select this one. I have listed the transition function. I don't know if it is not enough, we need to add more. Okay, but for the time being, I'm considering that this is enough. So let me consider a string BAA. So initially, what I'm going to uh, consider is the stack is empty. Okay, this is B, this is A, this is A, this is B, and then I'm going to consider stack is empty. So using one, I'm going to consider that I'm going to push jet. Okay, so let me just write using one push jet. If you want to remind yourself, you could write like Q naught, then without reading anything from the input tab, and then initially stack was empty, then change to Q1, insert jet. Okay, you did this using one, we are pushing jet. Now next one is I'm going to read B from input tab and then jet. Okay, I'm going to read B from the input tab and then jet from this text symbol. Okay, jet from this text symbol. In this case, what I'm going to do is using 7, push B here. So let me just write currently at Q1, B, reading B from the input tab, and then stack pointer. The top stack pointer is pointing currently at 7 jet. So I've written like this. And then what will happen? I'm just going to push B inside the stack. So now what will happen to this? This will be B and then so now pointer, the stack top pointer will be pointing towards B and then this one. Okay. Now what happened? Now using stick, oh, I don't know whether I've saved it or not. Okay. Okay. Now see here. Now I'm going to read A from the input symbol and then B from the text symbol. So using 6. Now using 6. What I'm going to do? I'm going to pop B. Using 6 is here. I'm going to pop B. So let me just write currently at Q1, reading A from the input, tab, and then from currently at B. So what happened? See like this. Okay, and then now popping B, it will be pointing towards jet and then A. Okay. Now currently at A. Now see here, using 2, I'm going to push A. So now let me just write using 2, I'm going to push A. Okay. Now let me just write currently at Q1, and then from the input tab, I'm going to read A. From the input tab, I'm going to read A. And then the stack symbol is jet. The top stack pointer is pointing toward jet. If it happens, what I'm going to do is I'm going to push A inside the stack. So now the condition will be, A will be present in here, and then and then the pointer will be modified. This is after pushing A, the stack top pointer will be really pointing towards A, and then the next one after reading A, it will be pointing towards B. Now, next one is currently at Q1, and then reading B from the input tab, reading B from the input tab, and then A from the stack symbol. So B, A, B, A. Where is B, A? Okay, fine. See here. Using 3. Let me just write. Using 3, pop A. So let me write. Currently at Q1, reading B from the input tab, A from the stack symbol, A from the stack symbol, A from the stack symbol, Q1, then replace A by epsilon. It means we are going to pop A from the stack. Pop A from the stack. So let me just pop it. Now, after popping, this will be epsilon. We're going to read nothing. And then what happened? It's up to you. Using 4 from the input tab, nothing. We're going to read. And then from the stack jet, either you want to go for this or this or this. It's up to you. So let me just write using 4. Let me just write using 4. Okay, I guess with this example I have explained PDA, how to design a PDA for a given language. So you should not, at the end, you should not write like this. I mean, you should specify, let me just write the transition function. Let me just write transition function are as follows. So 1, 2, 3, 4, 5, 6, 7, 8. These are the this is push down automata. Okay, and then my advice to you all is go back and then select another random string and try out by yourself. Okay, and then in my example, I have combined both. It's not that it's wrong. You can combine it, but go back home and then do it separately. One, design a PDA by acceptance by reaching the final state. Another one, design a PDA by emptying the stack separately. For the same example, you please do it by yourself like that, okay? And then a few more examples also, you please practice by yourself. Tomorrow I'll be continuing with this PDA again, okay? So once you understand, it's very easy, but for the beginning part, right, you need to practice from your end. So I won't say it's very complex or it's too easy like that. It depends on the way you're going to practice. Okay, if you're practicing it very, in a very refined way, then okay, fine. I'm going to stop the class. So please go back and practice.